EMD's 567 engine ruled American railroads for decades. Everyone knows that story. But there was another engine with more torque, higher power density, and better efficiency. Fairbanks Morse's 38 D8 1/8 should have been a revolution. Instead, history forgot it, not because it failed, but because it still runs today in submarines and generators worldwide. So, why did the more powerful engine lose to EMD's workhorse? The answer reveals everything about innovation versus what actually works. To understand why, we need to go back to where it all began. After World War II, American railroads faced a huge change. Steam locomotives, the giants that had ruled the tracks for over a century, were suddenly being replaced by diesel engines. Steam trains were impressive to look at, but they were expensive and difficult to run. They needed teams of workers just to keep them moving, had to stop constantly for water and coal, and broke down often. Smoke and ash followed them everywhere, making life messy for both crews and passengers. Steam was powerful, but it was slow, costly, and high maintenance. Diesel engines promised a better way. They could run longer without stopping, needed much less attention, and produced far less smoke and dirt. A single engineer could now do the work that once required a whole team. Railroads saw a chance to save money, run trains on tighter schedules, and keep passengers and cargo moving more reliably. Diesel power was smarter and cleaner. But switching from steam to diesel, railroads quickly realized that diesel locomotives had to be dependable and easy to fix. Engines needed to run every day without breaking down, and when repairs were necessary, parts had to be easy to get and swap out. Crews needed simple, standard designs and a service network that could handle problems anywhere on the line. Companies that could provide both the engines and the support system quickly became leaders in the industry. By the late 1940s, diesel engines were everywhere, and steam was fading fast. The old coal-choked trains, once the king of the rails, were retired, and a new era had begun. Diesel changed the entire railroad industry. Costs dropped, schedules improved, and trains became more reliable than ever. In just a few years, the noisy, smoky age of steam was replaced by a quieter, faster, and more dependable future. While diesel power promised efficiency, not all engines were created equal, and not all manufacturers were positioned to take full advantage of the post-war boom. But one company was ready to dominate from day one. Electromotive Division, or EMD, had been a part of General Motors since 1930, giving it a huge head start long before engine specs even mattered. During World War II, EMD focused on building diesel locomotives for freight, while competitors like Fairbanks Morse concentrated on marine engines. After the war, EMD could leverage GM's massive resources, including a nationwide network of service centers and mechanics trained on diesel technology through military work. This meant railroads could adopt EMD engines with confidence, knowing repairs, parts, and expertise were available everywhere. For newer players, no matter how advanced their designs were, the lack of support network made diesel adoption risky. Railroads were conservative, and executives wanted a low-risk path to modernizing their fleets. EMD offered exactly that. They had engines that were not only powerful, but backed by an entire ecosystem designed to keep them running smoothly. At the heart of EMD's dominance was the 567 engine. Introduced in 1938 as a replacement for the unreliable Winton 201A, the 567 was a two-stroke, V-type diesel engine designed for simplicity and durability. Each cylinder displaced 567 cubic inches, and the engine was built around modular power assemblies that included the piston, rod, liner, carrier, and cylinder head. These units could be swapped out quickly during maintenance without tearing down the entire engine, reducing downtime dramatically. Piston life jumped from the 201A's 50,000 to 100,000 miles to 400,000 to 500,000 miles, while Roots blowers ensured smooth power delivery, even on poor quality fuel. Mechanics loved the 567 for its forgiving nature. Its welded steel blocks allowed easy repairs, and parts were interchangeable across 6, 8, 12, or 16-cylinder variants. Training crews was straightforward, and maintenance was predictable thanks to EMD's nationwide support network. The 567 powered iconic locomotives like the FT, GP7, and SD9, delivering between 600 and 2,500 horsepower reliably. Its philosophy prioritized uptime over flashy innovation, earning the motto, "Good enough and always running." For railroads chasing efficiency and revenue, the 567 was a game changer that cemented EMD's place at the top of the diesel revolution. While EMD built its empire on reliability and support, another player approached the diesel revolution from a completely different angle. Fairbanks Morse, or FM, brought a mindset shaped not by railroads, but by the sea. The company, founded in the 19th century, had made its name producing scales, pumps, and early diesel engines, But it was the development of the opposed piston engine in the 1930s that defined its legacy. These engines, inspired by German Junkers designs, became a cornerstone of U.S. Navy submarines during World War II, where compact size, efficiency, and the ability to run continuously in confined spaces were non-negotiable. This background left a lasting imprint on FM's philosophy. According to them, engines should deliver maximum performance and efficiency, even if they demanded more from operators. After the war, FM saw an opportunity to bring its marine technology to the rails. It introduced locomotives in 1944, first with switchers and then with larger road units. The opposed piston design offered a high power-to-size ratio, fewer moving parts, and better thermal efficiency than conventional diesels. On paper, FM engines were brilliant. They could produce serious horsepower and run hard for long stretches. But in practice, their submarine routes sometimes clashed with the messy realities of American railroads. Railroads faced dust, dirt, inconsistent fuel, and crews that didn't always have specialized training. FM's engines demanded precision and care, and they were less forgiving when mistakes were made. Unlike EMD, which standardized parts and training to keep downtime low, FM focused on innovation and raw performance. Their locomotives impressed engineers with clever solutions and compact, efficient designs, but they intimidated operators used to engines that could withstand rough handling and quick fixes. While EMD built an ecosystem that made railroads feel safe adopting diesel, FM positioned itself as a challenger, an outsider bringing submarine-grade technology to a world that valued practicality over cutting-edge engineering. In the post-war diesel age, this contrast couldn't have been starker. EMD won railroads' trust with simplicity, support, and reliability, while Fairbanks Morse offered power and efficiency with higher risk and complexity. FM engines promised what many railroads needed, but required crews who could meet their demands. Fairbanks Morse's opposed piston philosophy reached its full expression in the 38 D818, an engine that turned conventional diesel design on its head. Unlike traditional engines with cylinder heads and valves, this two-stroke powerhouse used a pair of pistons moving toward each other inside a single cylinder, compressing the air-fuel mixture between them before ignition. The force generated by this combustion was sent to two crankshafts, one at the top and one at the bottom, linked together by gears. By harnessing power from both sides of the pistons, the 38 D818 reduced the number of moving parts, improved thermal efficiency, and achieved a compact size perfect for submarines and later for locomotives where space and weight mattered. What made this engine so remarkable was how much power it could deliver from a smaller footprint. The opposed piston design allowed for more complete combustion and better scavenging of exhaust gases, giving the engine impressive horsepower relative to its size. Engineers were drawn to its clever use of cylinder wall ports for intake and exhaust, replacing conventional valves with a simpler, more efficient system. Airflow was managed by a Roots blower or turbocharger, ensuring strong torque even at low engine speeds. It was built to maximize performance, pushing engineering boundaries rather than simplifying daily operations. Railroad crews quickly noticed the difference. Unlike EMD's 567, which was designed to be good enough and always running, the 38 D818 demanded respect. It could deliver exceptional power and efficiency, but it rewarded careful handling and precise maintenance. It was built for a high-stakes environment where every inch of space counted. Every drop of fuel mattered, and reliability was expected, but operators had to meet its demands. The 38 D818 embodied Fairbanks Morse's approach to dieselization: innovative, compact, and fiercely powerful, but not always practical for everyday railroad realities. It captured the imagination of engineers who valued clever solutions and cutting-edge design, yet it clashed with the conservative, downtime-averse culture of post-war railroads. In the Battle of Diesel Mines, the 38 D818 stood as a symbol of ambition and ingenuity, a reminder that in the race to modernize the rails, sometimes brilliance and practicality don't always align. The 38 D818 was a marvel of engineering, packing incredible power into a compact, efficient design. Against EMD's 567, it had clear advantages: higher torque, better power density, and superior fuel efficiency. The opposed piston layout allowed it to produce more brake mean effective pressure, meaning more power could be squeezed from each cylinder. For hauling heavy loads or running long stretches without stopping, this engine looked like a game changer. In marine settings where Fairbanks Morse had honed its designs, every ounce of efficiency and every inch of space mattered, and the 38 D818 excelled. But when this submarine-born powerhouse moved onto the rails, brilliance alone wasn't enough. The engine's complexity became its Achilles heel. Its dual crankshaft configuration made maintenance more complicated than the standard single-crank 567. 567. Repairs required specialized knowledge, something many railroad shops simply didn't have on hand. Unlike the clean, controlled environment of a submarine engine room, locomotives faced dust, dirt, and unpredictable conditions every day. Small problems that would be manageable in a naval setting, piston wear, oil leaks, and timing adjustments, could become major headaches on dusty main lines. Meanwhile, the EMD 567 kept proving why simplicity often wins in the real world. Its modular design and forgiving two-stroke operation allowed mechanics to train quickly, swap out parts easily, and keep locomotives running under imperfect conditions. While it couldn't match the raw horsepower or efficiency of the 38 D818, it delivered consistent performance with minimal downtime. For railroad executives, that consistency mattered more than peak power. Delays cost money, and engines that demanded perfect care were riskier investments. This clash of philosophies defined the core conflict of the diesel age. The 38 D818 embodied ingenuity and ambition, showing what modern engineering could achieve. Yet, on the gritty rails of post-war America, where dust, long hauls, and overworked crews were the norm, the practical, forgiving design of the 567 often proved more valuable. Submarine success didn't automatically translate to railroads. Raw power alone couldn't overcome the everyday realities of maintenance, dirt, and variable operating conditions. Fairbanks Morse brought entire locomotives built around that engineering ambition. The first of these was the Erie built, introduced in 1945. These cab units paired sleek styling with the 38 D818 engine and a 2,000 horsepower setup, promising railroads both power and modern design for passenger and freight service. On paper, they seemed like a perfect blend of performance and sophistication, a statement that Fairbanks Morse had arrived as a serious contender in the diesel age. In practice, the Erie built struggled to live up to the hype. The engines, designed for submarines and marine use, ran into problems with heat and air filtration when operating in dusty, variable railroad environments. Frequent breakdowns became a reality, and railroad crews quickly learned that impressive horsepower didn't automatically translate to reliable service. Confidence eroded as maintenance crews wrestled with the complex dual crankshaft engines, highlighting the same challenge that had defined the 38 D818 from the start. Raw power alone couldn't overcome the practical demands of daily railroading. Fairbanks Morse doubled down with the Trainmaster, or H2466, in 1953. This six-axle road switcher packed 2,400 horsepower, making it one of the most powerful locomotives of its time. It stunned the industry with its acceleration and hauling capability, earning respect from crews who needed brute force for heavy freight. Yet, the Trainmaster carried the same legacy of maintenance challenges. Its opposed piston engine required careful handling, and the dual crankshaft design meant repairs were time-consuming and complicated. Railroads were impressed by its performance, but wary of what it would take to keep it running day after day. Only 127 Trainmasters were ever built, a number that reflected both FM's engineering ambition and the practical limits of adoption. These locomotives became symbols of the core conflict that had defined Fairbanks Morse's railroad story. Innovation and power were never in doubt, but reliability and ease of use remained obstacles that railroads couldn't ignore. The Erie builts and Trainmasters showcased what submarine-grade engineering could achieve on land. They also reinforced a fundamental lesson. In the battle for the rails, practicality often trumps raw performance. The most advanced engine is only as valuable as it is dependable. Despite Fairbanks Morse's impressive engineering and the bold performance of the 38 D818, railroads overwhelmingly stuck with EMD. The reason was simple: standardization. By building fleets around EMD products, railroads could streamline parts inventories, simplify training programs, and reduce the chaos that came with unfamiliar or complex engines. Every shop across the country could work on that same engine, using the same replacement parts, without relying on specialized knowledge that only a handful of mechanics possessed. This uniformity meant faster repairs, fewer surprises, and trains that spent more time on the rails instead of in the shop. The EMD 567's modular design was central to this strategy. Individual power assemblies could be swapped out quickly, allowing locomotives to return to service in hours rather than days. In contrast, FM's opposed piston engines demanded careful attention, dual crankshaft know-how, and precise maintenance, which made unplanned downtime a real risk. For conservative railroad executives, no matter how brilliant FM's design was on paper, reliability and predictability were far more valuable than raw power or efficiency gains. The choice was about business sense. Railroads needed engines that would deliver consistent performance day after day, mile after mile. Every delay or breakdown translated directly into lost revenue and frustrated crews. In an industry where schedules were tight and freight was king, the mantra "good enough and always running" became a guiding principle. EMD didn't just provide locomotives, it provided confidence that fleets could operate smoothly without constant intervention. This focus on practical reliability over innovation cemented EMD's dominance. Even as Fairbanks Morse continued to push boundaries with powerful, sophisticated engines, the risk of downtime and complicated repairs kept many railroads from fully embracing them. Business priorities, not engineering marvels, dictated dictated the market. For railroads, success wasn't measured in horsepower alone. It was measured in miles traveled, trains on time, and predictable maintenance. Ultimately, EMD's combination of dependable design, modularity, and nationwide support created a low-risk, high-reward choice. Railroads could standardize across fleets, simplify operations, and keep trains moving efficiently, and that consistency proved more valuable than the raw innovation offered by competitors. In the post-war diesel age, practicality won, and EMD's 567 became the engine that defined American railroading for decades. Looking back at the diesel era, the question of who really won isn't as simple as it seems. Fairbanks Morse's 38 D8 1/8 didn't fail because it was poorly designed. In fact, it still works today in submarines and generators, running reliably and efficiently. Its design was ahead of its time. Many modern engines still borrow ideas from it. At the same time, EMD's 567 left a mark that's hard to beat. Locomotives using the 567 and its upgrades are still running on freight lines today. Its strength wasn't flashy power or complicated design, it was reliability. Mechanics could repair it quickly, parts were easy to replace, and it kept trains moving day after day. EMD knew what railroads needed after the war. Engines that worked all the time, easy to maintain, and didn't surprise crews with breakdowns. That's why the 567 became the standard for diesel locomotives. The story of FM and EMD shows an important lesson. Being clever or powerful doesn't always mean success. Even the best engine can struggle if it doesn't fit the real world. Railroads deal with dust, long trips, and crews who may not have special training. FM's engines were brilliant, but they needed more care than most railroads could give. EMD's engines might not have been the most advanced, but they ran well, were easy to fix, and earned the trust of operators. On the rails, being reliable mattered more than being the most powerful. In the end, the legacy of dieselization isn't about a single winner. Fairbanks Morse pushed engineering forward, creating ideas that still influence engines today. EMD delivered exactly what railroads needed and became the most important name in American diesel history. Power and clever design matter, but in railroads, practicality usually wins. Subscribe for more deep dives into machinery history.